So first thing, we have functions. Now what are basically functions? I just want to go through this thing because I think that these 2 points we have skipped during class, so I just want to go to functions again. So function was what? A relation f from a set A to set B is said to be a function. A relation is said to be a function when if every element of set A has one and only one image in set B. So it means that if I have set A and set B like this, so the set element is 1 2 3 4 5 and set B element is 4 5 6 7 8. So if I do a mapping, so 1 with 4, 2 with 5, 3 with 6, 4 with 7 and 5 with 8, you see every element in A, that is 1 2 3 4 5, have one and only one image, that is 4 5 6 7 8 respectively. So this type of relations will be known as function, and you have to write an f in the head of that thing. So this is a function. Now if you look at carefully, this function is nothing but fx is equal to x plus 3. How x plus 3? You see, if you put x as 1, you get 1 plus 3, 4. If you put x as 2, you get 2 plus 3, that is 5. So like this way you will get each elements of B by adding 3 with the corresponding elements of A. So this is how we get to know that how can a relation be a function. Now the second step is that if f is a function, here we see that this f is a function from A to B, that from A to B, the function is from A to B, and A comma B is an element of f. Now what is meant by A comma B? Here you see 1 is an element of A, this 1 is an element of A, and this 4 is an element of B. 4 is an element of B. Then we can say 1 comma 4, the ordered pair which is formed between the element 1 and 4, 1 comma 4 is an element of the function. Yes, because it follows 1 and 4 follows the function. And what is that function? Fx equal to x plus 3. So if these conditions are satisfied, then fa is equal to b. What do you mean by this thing is f of 1 is equal to 4. This 1 denotes A and this 4 denotes B, A comma B. So f of 1 is equal to 4. You see, I have said the function is what? X plus 3. Now f of 1 means what? In place of x I will put 1. So f of 1 is equal to, you put 1 plus 3, you see you get 4. Now if you put f of 2 will be equal to what? It will be 2 plus 3, that is equal to 5. So you get another ordered pair, that is 2 comma 5, that is also an element of f. So you will get elements, ordered pairs like this, with then you get 5 comma 8, 4 comma 7, like this way you will get ordered pairs. So where B is called the image of A, so I will say 4 is the image of 1 under f, under the function f. 4 is an image of 1, 5 is an image of 2. So like this way it goes, and A is called the pre-image of B. So if 4 is the image of 1, 4 is image of 1, then 1 is pre-image of 4. It's the opposite way, pre-image of 4. Okay, I hope it's clear. So we have this one as 1 is the pre-image of 4. So 4 is the image of 1, 1 is the pre-image of 4. So it's a two-way process. So we call it by this way. Now the function f from A to B, we have already told you that the function is from A to B. The function f from A to B is denoted by this thing, f colon A to B. Like this way we denote a function. So suppose we have a function like this, x y. We have a function like this, x y. Here we have 1 2 3 4, and here you have 4 5 6, like this way. And if I do the mapping, so I get 1 4 2 5 3 6 4 6. So now this is a function. Why this is a function? Because each and every element of x has one and only one image in y. Now if I have to denote this function, how are we going to denote this one? We'll write this one as x to y, like this way we denote. And you see here 1 comma 4 is an element of f. So f of 1 is equal to 4. So f of 2 is equal to 5. F of 3 is equal to 6, and f of 4 is also equal to 6. So like this way we see that if each element of A has one and only one image, then that relation is known as function. So this is what we have now. Today's topic was what? Some functions and their graph. Basically, graph is not included in your syllabus, so there is no point in doing graph. So we'll be discussing these different functions which we have. First, starting with identity function. Now, identity function basically means what? It means that you get your identity, just like identity card. But what does identity card shows? It's the information is what you have. Basically, it shows you only. Through the identity card, we get the idea that who are you, what's your age, and all. What's your roll number? It's like that. So identity function is what? It is nothing but function we have already know, that is fx. So fx is equal to x. This is an identity function. So whatever you put inside the function, you will get the same thing. It's just like the function is acting like a mirror. It's acting like a mirror. So if you put x in front of that, this is my function f, so you will get the answer as same thing. You will get the answer as f only. So this is what? Identity function. Now if I put f of z, you get z only. So like this way, whatever you put inside the function, you will get that element itself. So if I ask you, so if I have to make an ordered pair, so it will be like 1 2 3 4, 1 2 3 4. So if I have 1, so if I say f of 1, now f of 1 will be equal to what? 1, because it's an identity function. F of 2 will be equal to 2, f of 3 will be equal to 3, and f of 4 will be equal to 4. So like this way we do the mapping for identity function. So we're going to write here a, we're going to write here b, and this is my f, and this f is nothing but the identity function. Now if somebody asks you what is the domain of this function, actually we have already mentioned in here. So domain, so this was my function fx is equal to x. So the domain is what? Now domain, the definition of domain was what we discussed in last class. The definition of domain is, I'm going to write it here. It says that set of all values of x for which the function is defined. So we have all values of x for which the function is defined. So it's obviously from the given sentence, from the given definition of domain, it obviously means that we have to ignore all the points, all the values of x for which the function becomes undefined. So for this way, for the function to be undefined, we need to know two conditions. So what are the two conditions the function becomes undefined? So I'm going to write here function becomes undefined. So what are the conditions? This thing also we have discussed last class. The first condition is anything divided by 0. So if you come across a value of x for which the denominator becomes 0, because anything by 0 is what? Undefined. So if you come across a value of x for which the denominator becomes 0, then you have to reject that value. Like this way, if I have 1 by x plus 5, so you see if x is minus 5, then minus 5 plus 5, it becomes 0. So we have to reject minus 5, because minus 5 is that value of x for which the function 1 by x plus 5 becomes undefined. So like this way we have to reject minus 5. Now the second one is what? It is square root of a negative number. So we know that inside the square root there cannot be a negative number, or else it will become undefined. So whenever we come across square root of a negative number, you will say that to be undefined. So for all those values of x for which whenever you get square root of a negative number, you reject those values of x. So these are the two conditions in which the function becomes undefined. So if you look at this carefully, fx is equal to x, you see x, we can write this one as x by 1. So when I am writing x by 1, the denominator will never become 0, because it's 1 and 1 cannot be equal to 0 because it's a constant. How can 1 become 0? So this criteria is gone. We don't have to check that criteria, because for every value of x the function is defined for this criteria, because it's not becoming 0. Now the second one, square root. we can easily see that in the function there is no square root. So square root ही अगर नहीं है तो मैं नेगेटिव साइन क्यों चेक करने जाऊँ? तो ऑब्वियसली ये भी कंडीशन मुझे चेक करने का ज़रूरत नहीं है. सो व्हाट आई सी दैट इफ बोथ द कंडीशन फेल्स, it means what? The function will never be undefined. The function will never be undefined. So it is always defined. And if it is always defined, it means what? It means basically we are finding the value of x, and the value of x lies in what? Lies in the number line. So you have 0, 1, 2, 3, 4, minus 1, minus 1, minus 2. So dot dot dot, it goes like that. And number line is nothing but real numbers. Number line is a line in which every single point denote a real number. So here the domain for this function will be equal to R. The domain is R. It will be set of real numbers. Simple as that. Now we have to find range. Now range is what? The definition of range is quite simple. It is minimum value. You put range means what? The limit, the boundary which it thing lies. So minimum value, comma maximum value. That is my range. Minimum value, comma maximum value. So you have to find the minimum value of the function, and if you have to find the maximum value of the function. So how can I find the range of fx is equal to x? So for this one, what we are going to do is, you put, suppose I put f as 1000, f as 1000. So f of 1000 will give us 1000. Like this way. So if I put f of 100,000, so it will give us the same thing. So like this way, if I keep on increasing it, if I keep on increasing this number, then this number will also keep on increasing. So basically the maximum value will be infinity. The maximum value will be infinity. And what about the minimum value? Now again the same thing. If I do f of minus 10, so f of minus 10 is what? Minus 10. So again f of minus 10,000. That is what? That is also the same thing. So again, if you keep on decreasing, whatever value is inside here, you will get the same value. This value will also keep on decreasing. So here the minimum value is minus infinity. So again, this minus infinity to infinity is nothing but the number line itself. So again, the range will be R. The range will be set of real numbers. Because it's an identity function. We already told you, for identity function, whatever value you input, whatever value you give, the function gives out the same value. The function is nothing but a machine. It's a machine. It's a machine. What do you input? You input x, right? And what do you get? You get f of x. You get f of x. And for identity function, f of x is what? Is equal to x. So basically the machine doesn't do anything. If you give x, he will give out x. So that's why if the domain is R, then the range will also be R. Because whatever you are giving to the machine will output the same thing. So that's what identity function. So the graph is not important. Now constant function. Now what is a constant function? So a real function defined by y is equal to fx is equal to c. Y is equal to fx is equal to c, where c is a constant. Now constant like 2, 5, 6, they are all constant because they don't change their values. So here c determines a general constant. C determines every single number you have. So suppose we have fx. If I do a function fx is equal to 4, what does it mean? It means that if I do a number line, if I do a arrow diagram 1, 2, 3, 4, 5. So here we have 1, 2, 3, 4, 5. So if I do a mapping, so 1, you see fx is equal to 4. So it's a constant function. So I have to do what? F of 1. So f of 1, it will also be equal to 4 because it's a constant function. So 1 will go towards 4. Then f of 2 will be equal to what? F of 2 will be, that will also be equal to 4. F of 2 will also be equal to 4. So that is also equal to 4. Then f of 3 will be also equal to 4. This one will also equal to 4. So like this way we'll get a constant function. So for a constant function, what we have, if I have the machine function, if you put x, if you put fx, then fx will be a constant, that is c. No matter what you put inside the machine, it will always give you a constant output. That is what we have. So no matter what fruits you put, the juice will be always an orange juice. You're putting mango, you're putting a watermelon, whatever fruits you put, the juice will always be an orange. So this is how we have a constant function. So for a constant function, what is the domain? Again, you see fx is equal to c. So this c, it is basically c by 1. So quite simple. Anything by 0, no, not possible. Then again, we have no square root in there. Again, there is no square root in there. So this condition is also not able to follow up. So you see that this function is defined for all values of x. So whenever we see a function is defined for all value of x, the domain will be R. The domain is R. Now what is the range? Now range is equal to what? I told you range was what? It was minimum value comma maximum value. This is the range. So now you see that this machine, this function machine, that gives only one output, that is C. So if it gives only one output, what is minimum and what is maximum? So it is only C only, because it's just giving C. Is it? It's not giving 5 for someone, or it's giving 10 for something else. It's not doing it. It is giving C every single time. No matter what you put, it's always giving C. So there is no minimum or maximum value, because it is always C. So the range will be C, because other than C, nothing you get. So this domain, the domain actually is the value of the input, and the range is nothing but the value of the output. That is what we have. So we have constant function. Now we have polynomial function. So what do you mean by polynomial function? Now polynomial, it is basically what? Decreasing power of x. Suppose we have x to the power n, a x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus dot 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 a n minus 1 x plus an is equal to 0. So you see here, this way the power of x keeps on decreasing. One step you move in the right hand side, the power of x is keep on decreasing. So whenever you came across, actually this won't be equal to 0. Whenever you came across like this, where the power of x is keep on decreasing, then these type of functions are known as polynomial function. Now one thing to keep in mind, that n is an element of whole number. Now what does it mean? It means that if you have a function like this, square root of x, 4 square root of x minus 2x to the power minus 1 plus 4x square is equal this thing. Now if somebody asks you, is this a polynomial? No, it's not a polynomial. Why? Because the power will always be a whole number. It must be a whole number. So if you see this square root of x, the power is what? Half. Not a whole. Half is not a whole number. Again, the power of x is minus 1. Again, it's not a whole number. So these two elements makes itself not a polynomial. So they don't make it a polynomial. So this is not a polynomial. Now another thing, polynomial has a degree, and degree is what? Degree is the highest power of x. So here in this general polynomial, the highest power is what? This n. It's quite easy. So the degree is nothing but n. This is my degree. Now again, if I have an equation 7x square plus 2x plus 9, this is a polynomial, because you see decreasing power of x. This is a polynomial, and for this polynomial the degree is what? It is the highest power, that is degree is equal to 2. Degree is equal to 2. Oh sorry, the degree is equal to 2. Now you see, if you put equal to 0, now you recognize this thing. This is known as quadratic equation, because the power of x is 2, so it is known as quadratic equation. So like this way you will get different polynomial functions. Or else if I say x cube, if I have fx is equal to x cube, now this is also a polynomial equation. I don't care how many terms are there or not. If there is only one term, it's a polynomial. Or else I say fx is equal to x square. This is also a polynomial. So like this way you will get polynomials. Now for a polynomial, what is the domain? Now if somebody asks you, what is the domain for a polynomial? Again, let us pick a general one, ax square plus bx plus c. So what is the domain of this thing? You don't see anything divided by 0. There is no anything divided by 0. So the first criteria, what was? Anything divided by 0? I don't care, because there is nothing. Denominator is 1. I don't care. Now square root. Again, You see, square root is not possible for polynomial. So there is no way square root can come in. So if square root doesn't come in, then square root of a negative number is also not possible. So both the conditions are not valid in here. So it means what? The function is always defined, and whenever the function is always defined, the domain is R. So no matter what value of x you put, the function will never become undefined. Now you have to find the range. The range is equal to what? Now you don't have to think of, you just keep on putting values of x. What you will see, the minimum value will be minus infinity and the maximum value will be infinity. I'm just talking about the general one. Suppose you have x cube. So if I have to find the range, what is the range is what? Minimum value, minimum comma maximum. So if I have f of minus 1000, so f of minus 1000 is what? Minus 1000 whole cube. So it is very smaller. It's very smaller. So I will just take a small example. F of minus 10 is what? F of minus 10 is minus 10 whole cube. F of minus 10 is minus 10 whole cube, and for whole cube the minus sign remains and we have minus 1000. So whatever you put in here, the answer, the output you will get is the cube of that thing. So basically, if this one is small, then it is very smaller. So the minimum value will be minus infinity. Okay, and the maximum value will be again the same way. If you increase this one, the value will be cube, like this one, f of 1000. So f of 1000 is equal to what? 1000 cube. So it is more, it is becoming cube times more. So that's how we get the maximum value is infinity, minimum value is minus infinity. So for general polynomial, the range is R and the domain is R. Now we have some special polynomial. Now if you have a polynomial like this whose power is even number, now what happens to these polynomials? Now this one is for odd powers. Just write in here, this is for odd powers. Odd powers means x cube, then x to the power 5. You see x is also a polynomial, and we see that this x, fx equal to x, was what? Identity function. So x to the power 7. So all odd powers of x, the domain is R, the range is R. Now what is about the even power of x? So what happens for the even powers? So even powers of x, we have that domain. The domain will be same as that odd power, because anything by 0 is not possible and square root is also not there. So domain is R. Now we have to talk about the range. So what is the range in here? Now if you look carefully, you know one thing. So no matter what number you have, negative number, positive number, if you square that thing, you will always get a positive number. So x square or x to the power 4 or x to the power 6, all even powers will never be negative. They will never be negative. If they are never negative, when a function becomes never negative, then the minimum value will always be 0. Always remember this thing. When the value of the function is never negative, when it's getting never negative, then the minimum value will be 0. Simple as that. अगर कोई फंक्शन का वैल्यू कभी नेगेटिव नहीं हो सकता, तो उसका मतलब उसका मिनिमम वैल्यू 0 होगा, और उसका मैक्सिमम वैल्यू क्या होगा? तुम x के अंदर कुछ भी पुट करो, 100 पुट करो, तो क्या आएगा? 100 स्क्वायर आएगा, उसका मतलब 10,000. सो इट कीप्स ऑन इंक्रीजिंग, तो ये मैक्सिमम वैल्यू हो जाएगा इन्फिनिटी. सो दिस इज माई डोमेन एंड रेंज फॉर इवन पावर्स ऑफ x. ओके, चलो, तो ये हो गया पॉलिनोमियल फंक्शन. नाउ वी हैव रैशनल फंक्शन. नाउ रैशनल फंक्शंस आर व्हाट? फंक्शंस व्हिच आर एक्सप्रेस्ड एज fx by gx. तो अब तक हम लोग ने क्या किया? fx is equal to x, like this way we have we are having functions like this, और we have writing fx equal to x square. ऐसे भी मुझे फंक्शन मिला था. लेकिन अब क्या है? functions which are expressed in the form of fx by gx. जैसे कि रैशनल नंबर हम लोग पढ़े थे. रैशनल नंबर क्या होता है? functions which are expressed in the form of p by q, where q is not equal to 0. This was rational number. Now here we have rational function. So rational function is what? These are numbers which are expressed in the form of fx by gx. It is ratio of two different functions. This is known as rational function, where gx is not equal to 0. ये कंडीशन होना चाहिए, बिकॉज gx अगर 0 बन गया तो ये पूरी अनडिफाइंड हो जाएगा. ठीक है, तो ये हो गया मेरा रैशनल फंक्शन. नाउ व्हाट इज द डोमेन ऑफ रैशनल फंक्शन? तो डोमेन क्या होता है, एक्चुअली हम लोग ने पहले से ही किया हुआ है. तो सपोज एक स्पेशल फंक्शन दिया हुआ है एफ एक्स इक्वल टू 1/x, एफ एक्स इक्वल टू 1/x एंड दे हैव आस्क्ड यू व्हाट इज़ द डोमेन ऑफ इट. इसका डोमेन क्या है? तो इसका डोमेन क्या होगा कि फर्स्ट थिंग अगेन मेरा दो कंडीशन क्या था, व्हाट वाज द टू कंडीशन व्हेन द फंक्शन बिकम अनडिफाइंड, एनीथिंग डिवाइड बाय 0 एंड द सेकंड वाज व्हाट, स्क्वायर रूट ऑफ अ नेगेटिव नंबर. तो स्क्वायर रूट तो यहाँ पर है ही नहीं, तो स्क्वायर रूट के बारे में सोचना छोड़ दो. तो एनीथिंग बाय 0, अब ये कंडीशन देखता हूँ. तो अगर मैं 1/x देखता हूँ, यहाँ पर डिनोमिनेटर में x है, तो डिनोमिनेटर x है उसका मतलब ये x 0, ये डिनोमिनेटर 0 कब होगा, जब x 0 होगा. तो उसका मतलब ये है कि आई हैव टू रिजेक्ट द वैल्यू ऑफ x एट व्हाट 0. सो आई हैव टू रिजेक्ट 0 को मुझे हटाना है. और other than 0 if you put any number in here it will never be undefined. 1/1, 1/2, 1/40, you put any number other than 0 it will never become undefined. तो इसका डोमेन होता है r-0. I have to reject 0. अच्छा ऐसा तो हम लोग ने किया ही है बिकॉज x-5 इसका डोमेन क्या है, x-5 का डोमेन क्या है. तो अगेन स्क्वायर रूट नहीं है यहाँ पर, इसका बात नहीं आता. एनीथिंग डिवाइड बाई 0. तो अब मैं देखता हूँ ये डिनोमिनेटर कब 0 बनेगा. तो ये डिनोमिनेटर 0 बनेगा जब x इक्वल टू 5 होगा. तो इसका डोमेन क्या हो जाएगा, r माइनस इट विल बिकम 5. सो दैट इज़ माई डोमेन ऑफ दिस फंक्शन 1/x-5. तो ऐसे करके मिलता है डोमेन फॉर रैशनल फंक्शंस. नाउ द लास्ट थिंग वी हैव रेंज. व्हाट इज़ द रेंज ऑफ रैशनल फंक्शन? नाउ द रेंज इज़, इट्स क्वाइट सिंपल. अगर x के जगह में इफ़ यू पुट x एज हाफ, तो इसका वैल्यू क्या आएगा, इसका वैल्यू 2 आ जाएगा. ओके, सो इफ़ यू पुट 1/x के जगह में 1/5 पुट करो तो इसका वैल्यू कितना आ जाएगा, 5 आ जाएगा. तो इफ़ यू हैव, तो बेसिकली इसका वैल्यू जो है ये r होगा, इसका वैल्यू r होगा, सेट ऑफ रियल नंबर्स. इफ़ यू पुट 1 डिवाइड बाय -2 you will get this number. So you will get each and every values of x in here. ठीक है, 1/x में तुम x के जगह में कोई भी फ्रैक्शन पुट करो तो वो देखो 1 डिवाइड बाय 1/40 पुट किया तो इसका आंसर क्या आएगा, 40 आएगा. तो यू विल गेटिंग, अगर फ्रैक्शन पुट किया तो उसका वैल्यू क्या होगा, इंक्रीज कर रहा है, तो ये क्या होगा, इन्फिनिटी होगा. और अगर मैं यहाँ पर 1/40 की जगह 40 पुट करता हूँ तो ये दिस इज़ व्हाट, इट्स क्वाइट अ स्मॉलर नंबर. So this is coming out to be 1 second, it's coming 0.025. तो ये वैल्यू आ रहा है. तो what does it mean? It means that कि we can have smaller values of x, we can also have negative values of x also, negative values of fx, we can have smaller values of fx and as well as we can have bigger values of fx. अगर मैं फ्रैक्शन पुट करता हूँ x की जगह में बड़ा वैल्यू मिलेगा तो इसका रेंज जो है वो r होगा. The range will become r. Okay, now this is what we have of the domain and range. Okay, now this range, there is one thing to be noted for this range. 1/x, can you think of a value of x for which this 1/x becomes 0? Is there a value of x for which this 1/x becomes 0? तो x का वैल्यू तुम जितना इंक्रीज करोगे, the more you increase the value of x, 1/x will keep on getting smaller and smaller. Okay, 1/x will keep on getting smaller and smaller. तो 1/x का स्मॉलर तो होगा लेकिन 1/x कभी भी 0 नहीं होगा. There is no particular value of x for which 1/x becomes 0. तो इसका रेंज it will be like this, r minus 0, r minus 0. Why? Because it cannot be, 1/x can never become 0. 1/x कुछ भी हो सकता है लेकिन 0 कभी नहीं बन सकता है. Because if you think of any value of x, it can never be equal to 0. So this is what we have. Okay, so these are rational functions and this portion we will discuss next class.